Alright, today we are talking about polynomial division. There are two different ways to do this. Right? We're going to look at a way called long division, and we're going to look at a way called synthetic division. The first way we're going to look at is what's called long division. Now this is very similar to what you've always done in terms of basic algebra division. So if I have 10, and I'm dividing it into 8,472. How many times does 10 go into 84? 8. 8 times 10 is 80. We take away 80 and we're left with 4. We bring down the 7. How many times does 10 go into 47? 4. 4 times 10 is 40. Subtract, we're left with 7. We bring down the 2. How many times does 10 go into 72? 7 times. Subtract the 70, and we are left with 2. In this situation, we have a remainder of 2. Now, we could carry on a little bit further and figure out, what the decimal is, but for the purpose of what we're doing today, we're not going to, carry on any further. All right, so our final answer is 847, and we could put the 2 over the 10, which we're dividing by, which is 1/5. 847 and 1/5. Alright, so that is our normal division with numbers. And this really plays into what we're doing today. So if we look at this first example together, I start off saying always focus on the first term. We always got to focus on the first term. Here we got rid of the 8s. Then we got rid of the 4. Then we got rid of the 7. We kept breaking it down by getting rid of the first term. So if I focus on, in this situation, 2x cubed, my question is, what times x equals 2x cubed? So in this situation, what times x gives me 2x cubed? 2x squared. So I multiply the x plus 4 by the 2x squared to get 2x cubed plus 8x squared. Right? And I subtract 2x cubed minus x cubed, gone. 8x squared minus x squared, gone. Now, will this work out every single time that we eliminate both terms? Absolutely not. But this is a nice little benefit to us. Right, so I bring down the next term, negative 3x. Now, the problem here is that if I'm dividing by a binomial, I need to be able to divide into a binomial. Right, so I have to bring down two terms at once in this situation. And it's the same idea as before. So if I have x plus 4, I focus on the first term. X times what is negative 3x? Negative 3. So I'm subtracting negative 3x minus 12 to get 0. So my final answer here is 2x squared minus 3. The common mistake for a lot of people is that the double negative here. So the fact that this is minus a negative 12. Negative 12 minus a negative 12. So really what we have here is a plus 12. And that tends to throw people off from time to time. We go back and erase this one. We can now focus on this second problem here. So same exact idea as this first one. Alright, but there's one key thing we're missing here. X to the third, x4. Well, here we had x to the third, x squared, x, and negative 12. We need a placeholder. Alright, we have to rewrite this as 4x cubed plus 0x squared minus 11x minus 4. We always have to have a placeholder from everything from the degree, which in this case is that x to the third, down to the solo number. So if we had an example like this, x to the fourth, right? So if I have x to the fourth divided by x plus 1, really this has to be written as x to the fourth plus 0x to the third plus 0x squared plus 0x plus 0. We have to put 1, 2, 3, 4 placeholders in this situation. It always goes from that lead piece down to that individual number with no variable. Alright, so back to what we're doing here. Alright, so again, same idea. We focus on the front. 2x times what gives me 4x cubed? Well, here is 2x squared. 2x squared times 2x plus 1, so I'm subtracting 4x cubed plus 2x squared to leave me in this situation negative 2x squared. Bring down the next term because a binomial always has to divide into a binomial. So, question, 2x times what is negative 2x squared? In this situation, negative x. Negative x times 2x plus 1 negative 2x squared minus x, which leaves me with negative 10x. Bring down the negative 4. Alright? 2x times what gives me negative 10x? Negative 5. Alright, work through, I have a remainder of 1. Alright, so, in the end, just like we did with the regular numbers, we can put the remainder over the divisor. So our final answer here is 2x squared minus x minus 5 plus 1 over 2x plus 1. That's our final answer. So this is long division. It is really similar to what we did back in the algebra days, but now we're throwing in variables. My key advice is always, always, always focus on getting rid of the first term. Get rid of the first term, get rid of the first term, get rid of the first term. If you happen to get rid of 2 terms at once, that's great. Right? When we're working on division with a binomial, you always have to match up with a binomial. Right? And last but not least, placeholders. Always have your placeholders. Lots of points are lost by people forgetting to put in the placeholders. So if we come down here for a second, I look at problem 4. Right, problem 3 and problem 4, these are the ones where you have to use long division right here. We don't have another method in this situation when we have this trinomial set up. Right, so I'm going to focus on problem 4 right here. So right away I realized I need my placeholders. X to the 4th plus 0x cubed plus x squared plus 0x plus 1. Now the same ideas as before. If I have 3 terms, I'm focusing on 3 terms. A trinomial divides into a trinomial. So the question is, focusing on the first term, x squared times what gives me x to the 4th? X squared. So I'm subtracting x to the 4th plus x to the 3rd plus x squared. And that's going to leave me in this situation with a negative x cubed plus 0x squared. Trinomial divides into a trinomial, so we bring down the next piece. So x squared plus x plus 1, focus on the first term. What times x squared gives me negative x cubed? Negative x. Negative x cubed minus x squared minus x leaves me in this situation x squared plus x. Bring down the 1. Alright, so x squared plus x plus 1. Focus on the first term. Times what? Times 1. Minus x squared plus x plus 1. Nothing. So our final answer. X squared plus x plus 1 divides into x to the 4th plus x squared plus 1 and leaves us with x squared minus x plus 1. Alright, so there's our long division idea.